10.3, linear, quadratic, and exponential functions. We're looking at their equations from tables. So we're going to go ahead and I want you guys to look at all three of these examples kind of as a whole. And I want you to notice that in each of these we have three options and only three options. Each of these tables represents one linear, one quadratic, and one exponential function. And we're going to talk about how you can recognize it just looking at it, and we're also going to talk about how your calculator can give you this answer as well. So first things first, which of these examples do you think looks linear? The linear example is actually going to be example number 2. Take a quick look. We can see that my x's are just increasing by 1 every time. Right? So that means we kind of don't really need to worry about that. So all these are just increasing by 1. And on the right side, they are decreasing by 1. But every single step of the way, they're decreasing by 1, right? When they have a constant rate of change, we know that that's going to be a linear function. All right? One of these is quadratic. All right, your quadratic equation is actually going to be this first one here. Whenever you see numbers decrease and then increase again after that, that's kind of a clue that it might be quadratic until you get into some of these other functions here. Let's take a look at the relationship between these terms. All right, again, our x values are just increasing by 1 every single time. But my y values, well, let's see what they're doing. First, we see decrease by 7. And then we see a decrease of 5, and a decrease of 3, and a decrease of 1, and then an increase of 1, and an increase of 3. Okay, so we know it's not linear. But then we look at what's called the second differences after that. Okay, well, it looks like my first differences are increasing by 2, increasing by 2, again increasing by 2, increasing by 2, and finally increasing by 2. So if these numbers match, we know that we have quadratic. Okay, and then finally, we kind of know now that this last one has to be exponential. One of the ways we could know that by looking at it is because, again, on the left side, our x's are just increasing by 1, so we don't really need to worry about those too much. Okay, but on the right side, I'm going to skip the decimals because those are confusing. Let's just look at the bottom. To get from 3 to 6, aren't I multiplying times 2? And to get from 6 to 12, I'm multiplying times 2. Maybe you know 1.5 times 2 is positive 3. Right, so all of these values are being multiplied. You guys, if we're multiplying to get from one number to the next, that's when we know that we have exponential. All right, so now how can we do all of this kind of with our calculator? I'm going to do each of these examples here, and I'm going to try to go fairly quickly because I know it's painful to watch me type these in. Let's see here. So we're going to go to Stat Edit, not this. Okay, we're going to go to Stat Edit. And you can see that I already typed in the examples here on the first one. Now, what I want everybody to do before we move any further, and it's going to help you out a lot, is I want you to turn on your diagnostics. And to do this, you go to second 0, get this whole big list. If you click the x to the -1, it'll take you to the words that start with D. So we're going to go down to Diagnostics On. And you may remember what this does. Diagnostics On means that when we run our stat edit, it'll have R show up. So let's go ahead and let's look at my list real quick. These are the numbers from example 1. And I'm going to go to Stat, over to Calc, and I'm going to just choose an incorrect option, right? Like what if I choose linear regression, even though we know it's quadratic? Okay, well, can you see that R is not 1? So that means this might not be your best option. What if we go again, Stat, Edit, and now we're going to choose quadratic regression, which we know it is quadratic. See, when you run this, we do get an R value of 1. So to write this equation, in this case, right, it's got an A value of 1, so we got 1x squared, 0 for B, so do I need to write 0x? I do not. And then finally a positive 5 at the end. So my equation for this is y equals x squared plus 5. All right, so let's put the numbers in here for example 2. I'm going to go to Stat. You'll notice I don't have to change the left-hand column. So on the right, we're going to just go ahead and type these numbers over those. So -3 and -4 negative 5, negative 6, negative 7, negative 8, negative 9. So stats over to calc. Let's go ahead and just run the correct regression here, linear regression, right? Linear equations. And we get an R value of 1, perfect. And we've got our A and our B values to write our equation. So in this case, we've got y equals negative 1a, so negative 1x, and then a negative 7, so minus 7. So here's my linear equation. And last but not least, let's go ahead and get our equation for example 3. And we've never actually done this one before, so please pay attention. I'm going to put in my correct numbers in L2. So I've got 0.1875, 0.375, 0.375. Then I've got 0.75. It looks like I did not type this one in correctly today. I did. All right, and then I've got 1.5, 3, 6, and 12. All right, and it looks like I typed a 4 there. Man. Okay, so what we're going to do now is we're going to go stat calc. Now, we've never chosen this before. We don't want linear. We don't want quadratic. If you keep scrolling down this list, you get to option 0. It says exp-reg. This is the one we want. This stands for exponential regression, and it works the exact same way as all the other ones. Let's take a quick look. Go ahead and just go to calculate. And we get our equation, right? A is 3, B is 2, and to the power of x is what goes in our equation. So we've got 3 times b to the power of x, and b is, let's see here, 2. And that is our equation. All right, that is our equation, and we're going to call it a day. Okay, so let's see this actually applied in a couple of easy ways. We're going to go ahead and we're going to type this next table into stat edit, and this is a lot of calculator work today, but trust me, the more comfortable you are with this, the easier this stuff will be. Okay, so I'm typing in my x values, and now I got to type in my y values. So we've got 2205 and 2270, 2350, 2653, 3052, 3417, 3890, 4522, 5107, and 5724. All right, we're going to go to stats, and we're going to go to calc, and we're going to choose exponential regression. And really quickly, in this actual problem here, it should have told you somewhere to use exponential. All right, so let's kind of excuse that. Here we go. Click enter and enter again. And here we go. We're going to write this equation. And we're going to definitely round. So we've got y equals A, it says is 978.979. So we're going to say 978.98. And then B goes in these parentheses, and B is 1.199. So I'm going to say 1.20 to the power of x. Now, if you'll notice, this regression is not fantastic, right? It's 0.6, but since today we are assuming that it's exponential, we're going to go ahead and use this one, right? It's not 1 because this is a scatter plot. It's not a perfect equation. Okay, so what we need to do is predict the number of bacteria after 15 hours. Well, we can see that hours is an x value, right? Hours is an x value. So if we want to predict the number after 15 hours, all we got to do is plug in the number 15 for our exponents. Okay, so let's go ahead and get that done. We've got, and you can use these rounded numbers. So 978.98, parentheses 1.20 to the power of 15. And there's our answer. We've got 15,083 and 0.1, so I'm going to round down and just keep it here. So 15,083 bacteria. All right, problem 5, last one. The table shows the number of sea otters living in a bay beginning in the year 1988, right? So that might be important to notice. The year 0 is 1988. Use the data to approximate the number of otters there were in 2008. All right, so we're going to go ahead and we're going to go to Stat Edit again. This list is much shorter, which is great. Here we go. We've got 0, 1, 2, 3, 4. And I'm going to clear this. All right, we got 475, 447, 420, 395, and 371. Okay, we're going to go Stats, Calc. We want option 0 again for exponential regression. And just keep clicking enter there. So our equation we're getting is y equals 475.24. In the parentheses, our b value is going to be 0.94, which makes sense because isn't the number declining as we go right? They're decreasing, which means our number needs to be less than 1 inside the parentheses. Hopefully you made that connection. And then we've got to the power of x. All right, so this is asking us how many otters were there in 2008. Well, 2008 minus 1988. All right, this is going to give us 20 years, right? And if you want to do that math in your calculator, feel free. You type it in just the years, just like they are. So minus 1988, and we've got 20 years. All right, so to get our answer, we've got 475.24. 0.94 to the 20th power. And then to finish this off, all we got to do is plug it in. So we've got 475.24 times 0.94 in parentheses, which is raised to the power of 20, right? Because 20 years have passed since 1988. Here we go. And we've got 137.87 otters, which doesn't really make sense. So we're going to go ahead and round and say 100. Right, can't have partial otter. So we're going to say 138 otters. All right, make sure that you pay attention to what makes sense in the way that you round. Okay, this is the last regression we're going to learn in Algebra 1. You know linear, quadratic, and now you know exponential. Right, they all work the same way in your calculator. Just make sure you choose the right one. And if you're not sure what the right one is, look at that R value. You want the R value that's closest to 1. That's going to be your best regression for whatever table you get.